Aluminum, or Al, is element 13 on the periodic table. In Europe, it is pronounced aluminium, whereas in the US we say aluminum. Either way, it weighs 26.98 atomic mass units and is located in period 3, group 13 of the P block. Its electron configuration is neon 3s2, 3p3, and has 2, 8, and 3 electrons by shell. We classify aluminum as a transition metal, often considered a metalloid. At room temperature, it is solid. It melts at 933.47 Kelvin and boils at 2,743 Kelvin. The density of aluminum is 2.7 grams per cubic centimeter when the temperature is somewhat near room temperature. The heat of fusion is 10.71 kilojoules per mole, and the heat of vaporization is 284 kilojoules per mole. Based on the Pauling scale, aluminum has an electronegativity of 1.61. It has an ionization energies occurring at 577.5, 1,816, and 2,744.8 kilojoules per mole. The atomic radius is 143 picometers, and the covalent radius is 121 plus or minus 4 picometers. The use of aluminum goes as far back as ancient Greece. Greeks and Romans used aluminum salts for treating wounds. Some years later, in 1808, Humphrey Davy identified the existence of a metal base of the material the Greeks and Romans called alum and coined the term alumium, but later changed the name to aluminum. Aluminum was not produced as a metal until 1825, when Danish physicist and chemist Hans Christian Ørsted reacted anhydrous aluminum chloride with potassium amalgam, which produced a substance that appeared similar to tin. Friedrich Wöhler later retired Ørsted's experiments and concluded that the metal was pure potassium. He is regarded as the first person to isolate aluminum with the slight changes he made to the experiments. Although the process was simplified and made more cost-effective later, aluminum was still considered to be a metal of great value. In fact, Napoleon III of France is known to have held a banquet at which the honored guests were given aluminum utensils, while the others had to suffice with gold. With advancements in technology used for finding and extracting metals from the earth, we now know that aluminum makes up about 18.2% of the Earth's crust, making it the most abundant metal on Earth. Aluminum is mass-produced and used for a variety of things, most of which we come in some form of contact with every day. These include cars, airplanes, railway cars, cans, foil, windows, wire, heat sinks, paint, and other outer shells of electronics like the MacBook Pro. Aluminum can be reacted with hydrochloric acid or sodium hydroxide to produce hydrogen gas. Most of the time, aluminum is alloyed simply because it increases strength, hardness, and durability of the metal.
We can find phosphorus in period 3, group 15 on the periodic table, in the P block with symbol P. Its atomic number is 15 and has an atomic weight of 30.74 atomic mass units. It is categorized as a polyatomic nonmetal, or metalloid. Its electron configuration is neon 3s2, 3p3, and s2, 8, and 5 electrons per shell, respectively. It occurs in its natural state as a solid, much like many other metalloids. Its heat of fusion occurs at 0.66 kilojoules per mole, and heat of vaporization at 51.9 kilojoules per mole. The electronegativity of phosphorus is 2.19 based on the Pauling scale and has a covalent radius of 104 to 110 picometers. Its first ionization energy is 1011.8 kilojoules per mole, its second 1907.0 kilojoules per mole, and third 2914.1 kilojoules per mole. It was discovered by Henning Brand in 1669 in Hamburg, Germany, but it was not recognized as an element until 1777 when it was familiarized to the periodic table by Antoine Lavoisier. Phosphorus exists as two major forms, white phosphorus and red phosphorus. However, due to its high reactivity, it cannot be found as a naturally occurring element on Earth. The word phosphorus comes from a Greek myth and means light bearer. When translated into Latin, it means Lucifer, which refers to the morning star mentioned in Genesis. To Greeks, however, it most likely referred to the planet Venus, or perhaps Mercury. We know that phosphorus makes up about 0.12% of Earth's crust. Although it is not the most abundant element on the planet, there is definitely enough to go around. We extract phosphorus by way of phosphorus-rich minerals. It is possible to make pure phosphorus from phosphate rock. The rock is mixed with sand and pure carbon, which is then heated in an electric furnace. An electric furnace is a device for producing at very high temperatures. Pure phosphorus is produced in this reaction. It escapes from the mixture as vapor that solidifies into white phosphorus. Phosphorus is essential to human life in that it is a primary component of DNA, RNA, ATP, and phospholipids. Some of the first ways we were able to extract phosphorus from humans was by isolating it from urine and bone ash. In more conventional setting, phosphorus is used in fertilizers, compounds and detergents, pesticides, and nerve agents.
Cesium, or according to the IUPAC, Cesium, denoted Cs on the periodic table, is one of the less popularly known elements and is located in period 6, group 1 of the S block. Its atomic number is 55, so it has 55 protons and electrons, but 78 neutrons, giving it an atomic mass of 132.905 AMU. Cesium is classified as an alkali metal and has an electron configuration of xenon 6s2. It has per shell 2, 8, 18, 18, 8, and 1 electrons, respectively. Because cesium only has one valence electron, we can assume it reacts violently with dihydrogen monoxide. Cesium takes on the molecular phase of solid, unless of course heat energy is applied or removed. It only takes 301.7 Kelvin, or around 83.3 degrees Fahrenheit, before cesium begins to melt, and at 944.0 Kelvin, or 1240 degrees Fahrenheit, it boils. The density of cesium is accepted to be 1.93 grams per cubic centimeter at or around room temperature, and 1.84 grams per cubic centimeter as a liquid at its melting point. The heat of fusion of cesium is 2.09 kilojoules per mole, and the heat of vaporization is 63.9 kilojoules per mole. According to the Pauling scale, it has an electronegativity of 0.79 and ionization energies occurring at 375.7, 2234.3, and 3400 kilojoules per mole. The atomic radius is 265 picometers, which is larger than most common elements, but smaller than several others as well. The covalent radius is denoted as 233 to 255 picometers. The crystal structure of cesium is a body-centered cubic, as illustrated here. Now, if we back up a few years, give or take, to 1860, we find ourselves in Germany in the company of German chemists Robert Wilhelm Bunsen and Gustav Robert Kirchhoff. Bunsen and Kirchhoff performed spectroscopic analyses of Durkheim Mineralwasser, or mineral water for you English speakers. They named cesium after the blue lines they discovered in its spectrum from Latin cesius, meaning sky blue. Cesium can be obtained in pure form by a few methods. One such way is to combine calcium metal with fused or melted cesium chloride. This isolates the pure cesium and can later be extracted easily. Today, cesium is used for things like atomic clocks, centrifugation fluids mainly applied to isolation of viral particles and subcellular organelles. Cesium is also used for enhancement of several metal ion catalysts used in chemical productions like acrylic acid, methanol, styrene, and methyl methacrylate monomers. Isotope cesium-137 is a very common radioactive isotope used to emit gamma rays for industrial applications and practices, but is also the most common isotope among dirty bombs, or radioactive bombs. Among its more useful applications, cesium-137 has been used in hydraulic studies similar to those using tritium, a hydrogen isotope. Non-reactive cesium can also be found in your blood, but only in trace amounts.